hobbyists, and it's great to see a total mix of age groups and interests and demographics in the room, because what I have here is a whole mix of subjects. There's a bit of history, a bit of background of ARM, a bit of sort of how we do business and how we interface with the industry and how we make money, because that confuses a lot of people. And then part of the brief, which Brian wrote, not me, part of the brief was to talk about how it is that ARM continually manages to innovate all the time and continually produce sort of ever better and ever more leading edge products all the time. And that is a constant pressure within ARM, the pressure to innovate. It affects the way we see ourselves, it affects the way we behave, it affects the way we organize ourselves within the company and how we develop people and how we develop teams. So I want to have a little bit of a look at that as well, because I think it's the way we work is quite fascinating. But first of all, let's deal with some misconceptions. The first thing is that ARM doesn't stand for anything. It's a very frequent question that we get all over the world. What does ARM stand for? Answer, nothing, officially, nothing. I'll tell you in a minute what it used to stand for, and it stood for a couple of things in its lifetime. But officially, ARM doesn't stand for anything. The company is just called ARM. The second thing is we don't manufacture chips. And again, that surprises a lot of people. Fewer people than it used to, yes, but it does surprise a lot of people. And you'd be surprised how many people phone us up or contact us and say, I'd like to buy a Cortex A9, please. And we have to explain very carefully that we don't actually make Cortex A9s. We help other people make them. And if you want to buy a Cortex A9 from us, quite happy to sell you one, but what you will get is an extremely large archive of VHDL, which you will have to turn into a chip all by yourself. And we will charge you several $1 million for the rights to do that. If you want to buy a Cortex A9, please go to one of our manufacturing partners, one of our licensees. They will sell you one for about $10, much easier way to buy one. But we don't manufacture chips ourselves. We let other people do that. Number three, you might be surprised that is there as a misconception. But all over the world, I come across audiences who don't actually realise that ARM is a UK company. We are quoted jointly on the London Stock Exchange and NASDAQ, so a lot of people think we're an American company. We are, fortunately, very successful in the processor market. So a lot of people assume that we're Chinese or Japanese, but no, we're not. We are a UK company. Our headquarters, as Stefan said, is in Cambridge, 30 miles up the road. We were founded in Cambridge, and we're still there, and our headquarters is still there, and our primary quotation is on the London Stock Exchange. So we are a UK company, which is very unusual in the semiconductor industry. These last two are quite important. We don't know everything that our partners do with the products that they license from us. Our products, as you'll see, go into all kinds of places, from the obvious ones you all know about, like mobile phones and tablets, into things like digital cameras, network switches, modems, hard disk drive controllers, braking controllers, engine management systems, all over the place. Places that you see, places that you don't see. And we are not experts in all those fields, and we have no idea, in many cases, actually the uses to which our products are put. We simply can't track it. There are too many of them. Another example would be if your bank card has a chip in it, like all of ours do, but none of the Americans do, then it's very likely, actually, that the chip in there is actually an ARM design. Very likely. But I can't tell you for definite whether that one is, because the kind of people who make these products are extremely secretive, for obvious reasons, about what they do and how they do it, and the technology they use to produce bank cards. So it's not that we don't know. In that case, they won't tell us. Even our customers will not tell us what they do. And finally, we are very, very small for a semiconductor company. As Stefan's told you, we employ about 2,700 people these days worldwide, which sounds like quite a big company. We turn over just shy of $1 billion, which sounds like a lot of money. But we play in an industry which is much, much bigger than that. Semiconductor companies, if you think of companies like TI, Freescale, Samsung, Intel, the kind of companies that we deal with, they are all an order of magnitude
bigger than we are, both in the number of people they employ, the amount of money they make. Their global reach is far bigger than ours. So we are very small for the industry in which we play. And if you like, we sort of punch much, much higher than our weight. Now, for sort of the next 5 or 6 slides and so on, I just want to take you through a little bit of the genesis of ARM, a little bit of where we came from and how we do business. And to do that, I could just go and download our company presentation off our internal website. It's very pretty. It's got lots of lovely pictures in it. It's been drawn by our marketing department, and it's very lovely. But it's also, it's mind-numbingly, crushingly boring, because it's the kind of thing that we give to bankers and analysts. So what I've done is pulled out of that 7 numbers, which to me sort of allow me to tell the story of ARM. And the first 2 are these, 28 and 22. Would anyone care to hazard a guess what 28 and 22 signify in the context of ARM? Remember, you have to shout if you're going to talk. So,
I'll have a guess.
Go on.
28, the age of the company.
Close, but not quite. Actually, 22 is the age of the company. Right, 22. We were founded in November 1990, so we're just shy of 23. Now, what about 28? No, not quite. The number of employees originally was 12, actually, but 28 is the age of the ARM architecture. And again, it comes as a bit of a surprise to a lot of people to learn that ARM, the company, is only 22 years old. But the ARM architecture, the sort of architecture around which all of our products are built, and still are today, is actually 28 years old. It's older than we are. How many of you have heard of Acorn computers? Yeah, all of you. That's because we're in the UK. If I go and give this talk or a similar one, and I ask that question anywhere else in the world, nobody has ever heard of Acorn. It makes you realise how parochial Acorn's business was. But all their success, they were very parochial and very UK-centric. It's not quite true about anywhere else in the world. I've given similar talks to this in South Africa, New Zealand and Australia. And those 3 are places where probably about 50 or 60% of the audience would have heard of Acorn. It must be something to do with sort of sending computers to the ex-colonies or something. But there seems to be at least an awareness of Acorn. But okay, you've heard of Acorn. Acorn designed a product which they called the Acorn Risc machine. That's the first incarnation of the letters ARM, the Acorn Risc machine. And they designed that in 1985, 1984 into 1985, so about 28 years ago. In fact, 26th of April 1985 is the birth date of the ARM architecture, because that's the day when the first samples of their new chip, which they designed entirely in-house, arrived at Acorn's offices in Cambridge, which are right next door to the office which we're in today. And it ran code first time at 3 o'clock in the afternoon, 26th of April 1985. We know it that definitely. That architecture, say 28 years old, was then put into the Archimedes. I'm sure that's a machine that many of you will be familiar with. But as Acorn's fortunes started to slide, sadly, and Acorn, as we know, eventually died and was broken up and sold off in various incarnations. That architecture was picked up by Apple in about 1989. It was picked up by Apple for a product called the Apple Newton, which bombed as a product, and it died quite a long time ago. But they were looking for a processor for that, and came to Acorn and found the Acorn Risc machine and really, really liked it. But Acorn didn't have the money to productize it and sell it to Apple, because Acorn was slowly dying at that time. And Apple was kind of uneasy about buying it from Acorn at the time anyway, because they were competitors in the education market, in various markets across the world. So they hatched a plan, and that plan was to form a separate company to own that product and own that architecture. And that company would then make this product available initially to Apple, but then potentially to lots of other customers as well. And that company was originally called Advanced Risc Machines. That's the second incarnation of those 3 letters, Advanced Risc Machines. And it was founded, say, 22 years ago, very nearly 23, in 1989, in Cambridge, initially with just 12 employees. It had 3 parents, Apple, Acorn, and VLSI, who were the initial manufacturer of the chips, VLSI from the US. The third number that I'll give you, 913 million. Big number. Anyone guess what that is? If I put a dollar sign in front of it, does that help? Yes, it probably does. It's revenue from last year. All the figures that I give you here are generally taken from our 2012 figures. I'm not telling you any secrets because you can go and download our annual report and find them all. But $930 million is our revenue from 2012. So I've already told you we don't actually sell or manufacture chips. Where does the money come from? Well, here's how the ARM business works. That's our headquarters in Cambridge. That's where I work, right in the middle of that building, just there. And from that building, we produce designs, and we license those designs in source code form to companies that have very large manufacturing plants. That one's in Taiwan, belongs to a company called the Taiwan Semiconductor Manufacturing Corporation, and that's a chip foundry. Chip foundries are incredibly expensive. A state-of-the-art chip foundry these days will cost you between $6 to $10 billion to build. They are astonishingly expensive and very complex pieces of technology. So we let other companies do that. We don't want to do that. So we license our designs to companies that turn them into chips. And they then sell those chips to companies that manufacture stuff, like mobile phones, and they then sell those phones to people like you and me. That's actually Demi Moore. I just typed in celebrity holding phone, and that was the first. So, Demi Moore it is. So somewhere along that chain, ARM makes money. And it makes money in two places. The first place is charging for the initial license, and that is a very large fee, typically tens of millions of dollars for our state-of-the-art designs. That's the right to take that design and turn it into a chip or a range of chips. The second place we make money is when one of these companies sells or ships a chip, and we charge what we call a royalty, and that's a few cents per chip. It's about 10 cents a chip. Doesn't sound like a lot of money, but I'll tell you in a minute just how many chips these guys make every year. And when you multiply 10 cents by a very large, it actually comes to quite a lot of money. And last year we made about $340 million in licensing, and we made about $480 million, just over 470, in royalties, and we made $100 million doing other stuff. The other stuff is the bit that I do, things like supplying training courses and selling tools and models and supporting technology and all sorts of other bits and bobs. But you can see that the bulk of our revenue, and it's getting bigger all the time, the bulk of our revenue comes from that royalty. I'll unpack some more numbers about that in a minute, but one of the most important things to learn from that business model is that the pipeline is very, very long. And this explains part of the reason why analysts have a huge problem trying to determine ARM's share price. And ARM's share price goes up and down all the time. It's quite worrying sometimes, but it does. And the reason is that analysts find it very hard to sort of work out how much revenue is stored in this huge pipeline. If you think about the products that we're developing now, we spend 2 to 3 years developing a new processor or a new processor design internally. Once we've finished that, we'll license it and we make some money. And then our partners, our licensees, will spend another 3 to 4 years taking that design and producing a chip with it, or a range of chips. And we don't start earning royalties until usually about 7 years. The lifetime of that product is potentially 20 plus years. We still make a considerable amount of royalty revenue from the ARM7 TDMI. You remember that? 1995 that chip dates from. And we still make a lot of royalty revenue from a chip that is very, very nearly 20 years old. So the pipeline continues to generate money for a long time, but it takes a long time to start generating money. Okay, here are my final 4 numbers out of my 7 numbers. 1B, Q308, yeah, okay, it's not a number, it's got some letters in it. But that was a sort of slogan. I've got a t-shirt with 1B, Q308 written on the back, which John very kindly gave me, in Q3 of 2008. Because that marked the first time that our partners, our licensees, had shipped 1 billion chips in a single quarter. That starts to give you an idea of the rate at which our partners are manufacturing devices. 1 billion a quarter in 2008. Just to be naughty, it took the company that owns the x86 architecture, name I cannot bring myself to speak. It took them about 20 years from a standing start to ship 1 billion pieces of x86 devices. Our partners ship 1 billion chips about every year. About every year. Now then, what's this one? 2.4 billion. That was the quarterly shipment rate in Q4 of last year, 2.4 billion. So you can see from Q3 of 2008 to Q4 of 2012, the shipment rate has more than doubled in chips per quarter. 8.7 billion, you can probably work that out. That was the total shipments for the whole of 2012. And the 34.8 billion is the cumulative total to date of ARM devices that have actually been manufactured. Well, to the end of 2012, it'll be well over 45 billion by now. And someone pointed out recently that there are more ARM chips in the world than there are physical arms on the world's population, which is quite a nice comparison. What on earth people do with them, I really don't know. A very quick ARM history. I'm not going to go through every tick on this timeline, but I've just got a very quick ARM history. ARM 1, 1985, that was Acorn computers, and they put it into the BBC machine, which you can put into the Archimedes. ARM was founded very early 1990. Our first chairman and CEO, a chap called Robin Saxby, I'm sure many of you will have heard of, now Sir Robin Saxby. He was CEO for about 12 years, retired in 2003, 2004, and it was him who's really credited with inventing this IP licensing business model, and in so doing kind of invented an industry which ARM has gone on to be very successful in. It's a myth, actually, that Robin Saxby founded ARM. He didn't. The original 12 employees all came out of Acorn with 1 or 2 from Apple, and Robin Saxby was not one of them. He was headhunted very shortly after. So if anyone tells you Robin Saxby founded ARM, it's not true. The Apple Newton came out as a product in '93. That was the product that catalysed the formation of ARM, and then so the Apple Newton unfortunately died. But a key date, the same year, ARM signed a license with Texas Instruments, TI, for a design that TI were working on with Nokia for a new chipset for a mobile phone. This was actually the first time that anyone had combined for a mobile phone the application processor and the DSP for running the baseband on a single silicon device. And that chip was bought by Nokia, and it was so successful that Nokia rolled it out through its entire product range, and within 4 or 5 years, ARM had captured about 95% of the entire mobile phone market. So that license there really drove ARM's initial success and drove it right up to IPO in 1998. We still have about 90% of the mobile phone market, and it's a very, very important market for us. But we've moved out into lots of other things, as I'll show you since then. Our current office, we moved there in 1999, just about 3 months after I joined ARM. And Warren East took over as CEO in 2001. He came to us from Texas Instruments in Bedford, in fact. We reached a cumulative total of 10 billion chips in 2007. That's Warren cutting a cake to celebrate that, and there was the 1.25 billion. We entered the FTSE 100 in 2010, and last time I looked, we are currently number 35 in the FTSE 100, which is really quite a nice achievement. We are, I think it's slightly more valuable than Sainsbury's, but not quite as valuable as Rolls-Royce. Pretty close, pretty close. And we now have a new CEO this year, Simon Siggers, and we have sold nearly 1,000 licenses for our designs so far. We employ, so these days it's about 2,700 as of today. We have 29 offices, so we're worth about 14 billion. And it's a privilege actually to be able to come here and talk to you about a British success story, a very homegrown British success story in an industry which is not regarded as historically and traditionally British. So very pleased to come and tell you about it. A technical timeline, again this is probably less appropriate to this audience, but we can divide that into the sort of Acorn days and the ARM days, and the divide there is 1989, 1990. ARM 1 and ARM 2 were produced by Acorn. This is the ARM 2 is the chip that went into the Archimedes, and that was the first commercially available Risc processor in the world. ARM6 is the product that went into the Newton. It was designed in 1991, and we've gone on to design a huge range of products. And if you look at the dates, you can see how quickly we turn things out. We started with numbers. We had ARM6, ARM7, ARM9, ARM10, and ARM11. And then in about 2004, we rebranded everything under this brand that we currently use, the Cortex brand. And that started with a microcontroller called Cortex M3, and it went on for real-time and application processors, which are called Cortex R and Cortex A. And we don't have time today to go into the technology. If you want to invite me back, I'll quite happily come and tell you all about the technology at a future time. Currently, we've just announced announced 2 years ago, and we announced products last year on a new version of the architecture. It's a 64-bit architecture, and Cortex A53 and A57 are the top of the range applications processors which support 64-bit architecture. But okay, let's delve a little bit into markets. I've hinted at some markets which we're very prominent in, and I've hinted at some markets perhaps that we're not so prominent in. This is based on figures for 2012, and you can see the markets in which we are very, very strong. Things like smartphones and what we call feature phones, which is the sort of the phones that maybe allow you to send email but don't let you browse the web and so on. Low-end voice phones and portable media players. We have an extremely strong position in those markets, 90% plus of market share, and you can see that that translates into several billion devices. In case of smartphones, 2.2 billion devices shipped in 2012. And we've not quite saturated those markets, but we have a very strong position in them. But there are other markets that you might not be aware of. There's digital cameras, for instance. 80% of digital cameras are based around ARM processors. But people don't buy you don't buy a camera based on what operating system it runs or what processor it has in it. So people tend not to know that. We also have, if you have a printer at home, we have 70% of the market for print controllers. So if you have an HP desktop printer, for instance, that will have an ARM controller controlling its print heads. But you don't see that. Another one that people don't, we have 90% of the market for hard disk drive controllers and solid state disk drives as well. But again, you don't see those. You buy a laptop, it has a hard disk in it. There are about 4 companies in the world that manufacture all the hard disk drives that we use, Seagate, Toshiba, and 1 or 2 others. All of them use ARM to control the disk drive head. There are other markets in which we've only just started to form a presence, things like automotive. We have quite a strong presence in automotive infotainment and navigation. So, if you have a sat-nav, chances are that's ARM powered. But if you have an engine control unit in your car, the chances are that isn't. And we're only just starting to move into that. And we've only really penetrated about 8% into that market. And likewise, the microcontroller market, we only have just under 20% of that. But look at how big these markets are. And this is the problem the analysts have, working out how much of that market can we capture. Because if we capture a significant proportion of these markets, they will dwarf those ones. And those ones are the ones that make us $1 billion a year. So the potential is huge. So if you want to look ahead and think, well, where will we be in 5 years' time, 2017? Well, there's obviously the smartphone. We expect that market to grow 20% a year because lots more people are buying smartphones. There's only about 1 in 10 of the world's population have a smartphone, so there's a lot of growth there. Mobile computing, that's the tablet market. We expect that to grow 20% a year too. So there's lots of growth there. Likewise, networking, 5% a year. Smart microcontrollers, we expect that to grow 5% a year. Lots and lots of potential there because we only have 20% of this market, and 20% of 11 billion would be a lot, but 80% of 11 billion would be a huge amount. And what about this one? This is one that people talk about all the time, service. And this is where you cannot open the press, or certainly the trade press, and very often the financial press, without hearing talk about a battle between ARM and Intel for the server market. Which I have to say really annoys me. I don't like it being presented as a battle, but that's the way they like presenting it. But the desktop PC and server market. So what's our strategy for getting into that then? Because this is one of the highest profile markets we're attacking. Well, remember how long that pipeline is. We have to play a very, very long game to get into that kind of market. So if you look right back to 2008 and then project it forward to 2017. In 2008, we started developing server class solutions based on our original 32-bit architecture. we started to license that to partners in 2009, 2010. Then we started licensing that to the wider world at the end of 2010. In parallel, we started developing a new technology, a new 64-bit technology, which is capable of attacking that server marketplace. We started developing that in 2008. Right? It won't come to fruition until 2017. It's a very, very long game. We started licensing that only 2 years ago. And we won't start licensing it properly until really the end of this year. So, translate that into events in the marketplace. We seed the marketplace. We've invested in 1 or 2 server companies. Early partners adopted in the middle of 2009. 32-bit ARM servers were announced in 2011 and actually deployed in 2013. And at our TechCon show this year, just a month ago in Santa Clara, we were able to show ARM 64-bit server solutions. That's 6 years after we first laid down the foundations of that technology. It takes a huge amount of time to come with this. So what about that in terms of market predictions? Well, today we have last year we have 0% of that. Even today we have less than 1% of that market, but we predict we'll have 10 to 15, in fact 20% of it by 2017. So you can see even to get to 20% of the server market will take us 9 years. Long, long time. And you know, we're finding that in many of our markets we are well over 80% of market share, and getting beyond that is extremely difficult. So we need to introduce new markets and new technologies. New markets in Trust Zone, which is a secure solution for things like digital rights management and secure payment solutions. Multi-core processing. Only 10% of smartphones were multi-core in 2011. It's nearly 100% now. And almost all of those are based on ARM multi-core solutions. We developed ARM multi-core solutions first in 2003, and it's taken 10 years to get to where we are today. Mali's our graphics cores, and we're now shipping about 300 million units of graphics processors in 2012. That's taken nearly 7 years to get to where we are. And 64-bit, we started developing that in 2007. It won't reach volume production until next year. Very, very long game. So that's a little bit about who we are, what we do, and kind of how we do it. So just want to look now in sort of inside the company a bit. How do we organise ourselves, and how do we work together? What do we see as most important? Well, this, as you can imagine, this comes from our HR department. Yes, you recognise those, don't you? We are a people who connect, collaborate, and create. Now, actually, you may laugh at that, and you may be cynical, and I would be the first one to join you. But actually, I think ARM really believes this. Really believes this. That you don't produce the amount of innovation that we do unless you really harness the collective intellect, if you like, of nearly 3,000 people spread out across the world. And you have to work very hard to connect them together. You have to give them the tools they need to collaborate and give them the opportunity to create. I think we're very good at that. But we are very, very diverse, and it's a huge problem. So we have 29 locations as of the middle of this year. There they all are. Not all of them are processor design centres, but we have 29 locations. We are incredibly diverse. 2,700 people, 30 sites, 15 countries. We have over 50 nationalities working for ARM. Goodness knows how many languages they speak, but I'm not. We're still 30% British, but 70% non-British. That has 2 sides at that point. But the average age of the company is only 37. Very young. Younger in Asia. Certainly at some of our offices in Asia, almost all the employees are below the age of 35. Average length of service, only 4.5 years. So ARM is 22 years old, as we found out, but the average length of service of most of our employees is less than 5 years. I'll get on to our sort of approach to management later, but we have over 600 managers in the company, out of just under 3,000. That's about 1 in 4 or 5 of the company are managers. That means we promote people very quickly, and we have a very, very strong philosophy about developing leadership skills within people very quickly after they join the company, because then we can allow them to start leading teams and start showing their skills. We're still just about half of us based in Europe and the UK. Most of that is in the UK, and about a quarter in the US, with the rest split between India and the Far East, mainly China, in fact. For your information, we're organised into a series of divisions internally, which are organised around the major activities that we do. Processor IP is by far the biggest division. There's about 800 people work on processor design within that division. Physical IP is things like cell libraries, it's individual transistors, right down to that level within memory systems and chips. System design is the division that produces things like compilers and software development tools and debuggers and so on. Media processing produces graphics. Services is the division which I work in, which provides training and documentation and design services. And Secure Services division produce things like bank cards and secure payment solutions. And our very own newest division, which was only formed about 3 months ago, the Internet of Things business unit. And I don't think we even quite know what the Internet of Things is yet. We're trying to work it out. So we set up a business division to think about it. And when they work it out, I'm sure they'll come back and tell us. But let me just show you the original vision that 12 people came up with in 1990, actually in a barn at Swaffham Bullbeck, just the other side of Cambridge, which was ARM's first office. And later on, I'll show you ARM's vision today. You can see actually it's very similar. To design competitive, low power consumption, high performance, low cost processors, which become the accepted standard in the markets they address. There's nothing like aiming high, is there? And then there's a bunch of other stuff that they can do as well. But nothing like aiming high. They aimed right from the beginning to become a standard. And I think you'll find they have. Here's ARM's vision for today. I got this off our website just this afternoon. These days, it's not good enough to have a mission statement. You have to have a vision statement and a mission statement. So the top one is the vision. And it's a world in which all electronic products and services are based on energy-efficient technology from ARM, making life better for everyone. It's a good mission statement. It's all fuzzy and green and energy-efficient and eco-friendly and making life better for everyone. But the vision, the mission down here, the bottom, is strikingly similar to this one. Become the standard. Become number one. The vision, 22 years later, is essentially exactly the same from the one they started out with. So you then have to start unpacking that internally. This is from internal HR presentations. So how do you realise that mission in an industry where you have to innovate at the most incredible rate? Well, pick out things like this: teamwork. Remember that? Connect, collaborate, create. Teamwork is one of the most important things as far as we're concerned. An engaging environment for ARM employees where we develop personal and collective potential. We are very, very strong on that. And very strong on the fact that returns don't just belong to our shareholders, they belong to the employees as well. That's very, very important. So you unpack that even further. Unpack that into ARM as one community of people with common shared values. And I actually believe that is true. The vision says, design energy-efficient microprocessors. The entire company, literally the entire company, is focused on that, and that alone. Because that's what we do. That's what makes us money. That's what keeps us going. And that's what keeps us in the marketplace. So the entire company, literally, is focused on that. And I've shown you how diverse we are, and how many people we are, and how many languages we speak. We have to work extremely hard at channels of communication within the company that allow the whole company to work really as one team towards that. And we are also very hot, I believe hotter than many other employees I've come across. I've worked for a few in my time on providing opportunities for employees to develop their potential. Because if we can't provide that development potential better than elsewhere, what happens? Employees will simply go elsewhere. So we are extremely hot on that. And internally, this is internal stuff, right? This is probably the closest to a secret I'm going to tell you today. Internally, we are all of us, right, from the CEO downwards, we are all of us benchmarked every single year on what we are privileged to call the ARM values, or the ARM behaviours, the ARM expectations, if you like. And okay, number one is delivery of results. Did you actually meet targets this year? Did you design that thing? Did you ship that thing? Did you manage to test that thing and make it work? Did you fix that thing? Delivery of results is number one. But there are a bunch of other values too, and this applies to everyone in the company. Things like innovation. It doesn't just apply to R&D. It applies to every group in the company, including the trading division, which I work in, including the HR division, including all the support functions. Everybody, every year, is rated by their management team on how innovative they are in what they do. And it's a value that goes from top to bottom in the company. Also, things like being focused on customer. Everybody is benchmarked on how focused they are on what they're doing for customers, whether they're working on internal projects or external ones. How does that apply to one's customers? And how can you better serve them? I'm not bothered with that one. But I say, we're very hot on development of managers because we believe that teams are what produce results, and teams need leaders, and we promote people very, very young, and very, very soon after they join the company. So we have 600 managers out of 2,700 employees, 1 in 4. And the average length of time someone's been in the company is less than 5 years. You can see how quickly people are enabled into leadership positions with their own teams and their own goals, and all those teams are benchmarked against those values. And we believe giving people responsibility early on, because managers and leaders are responsible for the results the company produces. And that's very, very important to ARM and the way we do things. And communication. We have to be extremely hot on communication. This personal communication, this stands for the ARM feedback and development system. This is how you are rated by your manager and how you are sort of benchmarked against all of those values, individually, every year, by your manager in a one-to-one communication process. We have an extremely effective internet. Our CEO writes a quarterly letter to everybody in the company describing what we achieved last quarter, what are our goals for this quarter, how are we doing against that, what do the analysts think, what are the priorities for the next year, and so on. And that letter is sent out every single quarter, personally by the CEO, to every employee in the company. Our directors visit every office. How many were there? 30. Our directors visit every office every year to answer questions from the people on the shop floor, if you like. We organise a lot of internal conferencing, engineering conferences. We every year, for instance, bring together nearly 500 out of our population of about 1,800 engineers to the UK for an engineering conference. Imagine what that costs, bringing people from 30 countries to the UK, 500 people every year, to talk through what engineering challenges the company faces this year and what we need to put in place to make sure that we meet those challenges. Organisational development conferences, graduate conferences, sales conferences, innovation days, as well. All of these things which the company encourages people to communicate and cooperate and collaborate all the time. Okay, that's internal. All of that exists in an industry which changes so fast. Sometimes you have to sit down and just take stock and you realise how fast the industry changes. This is a die shot of the ARM1 from 1985, as designed by Acorn. For those of you that know anything about chips, it was designed on 3-micron technology, which means each feature on the chip, each wire, each gate, each transistor is roughly 3 microns across. That sounds very small, but these days that's massive. It had approximately 6,000 gates in it, which is about 20,000 transistors, and it's 7 millimeters on the side, 50 square millimeters of silicon. And it went into the Archimedes machine. One of the smallest processors we do these days, Cortex M0, is 1/10,000th of the size of that. This is a span of only 23 years, 24 years, and it's gone down 10,000 times in size. It's built on a feature size of 20 nanometers. Compare that to 3 microns, 20 nanometers. It has roughly 8,000 gates, so it's roughly the same complexity in terms of the number of gates it has, but it's 1/10,000th of the size. and it's significantly more powerful in terms of what it can actually do. But at the same time, we produce processors like this. This is a dual-core Cortex A9, which is the application processor that you would find in many, many mobile phones these days. And as you can see, it contains a graphics core. There are 2 processor cores on here, and a whole bunch of system stuff. And this is actually roughly the same size as the original ARM 1, 20-odd years ago. But it contains 100 million gates. It's that much more complex, and it's that much more powerful, and it uses a lot less electrical power than that did 20 million years ago. So the industry changes at a rate which is almost beyond belief. We show you the environment that we work in, the sort of competitive pressure we work in, that changes too. Our CTO, a chap called Mike Muller, was presented with this. So it's a plastic obelisk. It's about that big, and it sits in a display cabinet in our reception. You can go and see it if you like. And it's a plastic sort of perspex obelisk, and embedded in it are a bunch of chips. And those were, in 1992, those were the most popular chips on the market. There's one from ARM. There you go. That was the ARM 7. There's things like Intel, IBM, TI, Digital, Motorola, HP, National, AMD. They're all different architectures, different chips, different instruction sets, different technologies, and there were about 13 of them. There they all are, laid out, in 1992. In 2012, there are 4 left. 2 of them have between them about 98% of the market. ARM and Intel's x86 architecture. Spark and MIPS, they're still around, just. But they are decreasing in their impact every single year. But as of last year, there are only 4 out of those 13 left. So ARM has come a long way, and a lot of competitors have disappeared too. So the pressure on us, if you like, to continue innovating just gets higher and higher and higher all the time. But the vision really has stayed the same. That vision from 1989 become the accepted standard, and our vision from this year be the world's #1. I think we are actually the world's #1 processor architecture. We are certainly the most widely licensed and widely used 32-bit processor architecture in the world, and very, very well on to becoming the world's #1 architecture. We have about 32% of the world's processor market. Full stop. About 32%. If you take 32 bits, we have far more than that. Over 27 years, we've learned quite a lot too. And this slide largely comes from a set of lessons which our retiring president presented to the company at a roadshow about 2 years ago. And this is 27 years of things we've learned about the industry and how to perform within it. First, top right, isn't everything? If you draw a diagram, a sort of evolution of processors, it typically starts bottom left-hand corner with the old slow one from a long time ago, and it goes upwards and to the right in terms of performance. And everything goes upwards and to the right. And the next one has to be better and more powerful and more power efficient and whizzier and faster than the last one. So top right tends to be what everybody pushes towards, but that isn't everything. Remember, I showed you a slide with the total market size of the microcontroller market. It's almost bigger than every other market put together. About 11 billion chips a year, potentially, in the microcontroller market. The microcontroller market isn't top right. The microcontroller market is way down here. It's small, cheap, mass market, and low cost. And when we rebranded everything in 2003 with the Cortex A microcontroller, we started to realize that bottom right is just as important as top right. And in terms of future revenue, possibly more important. Designed once, used many times. ARM has often been called the outsourcing house of the processor industry because we now design the processors that everybody else uses. If you go back to 1992, that obelisk, and you had 13 competing processor architectures, all owned by different companies, all maintained by different companies, and all designed by different companies. So they all had to take on the entire cost of ownership of their own processor architecture, which is huge. You've got to manufacture tools for it, you've got to support it, you've got to manufacture chips using it, you've then got to sell it and support it. It's a massive cost of ownership. That cost of ownership now, across 300 companies that have licensed our designs, is split 300 ways. And ARM, if you like, is a huge processor design outsourcing house. We design processors once. Other people use them many, many, many times. That way the industry benefits from a low cost of ownership. If you are around ARM or talk to ARM for more than about 10 minutes, somebody will use the word partner. Because right from the beginning, we've never talked really about customers. We always talk about partners, and that's absolutely crucial. Because remember I showed you how our business model works. We license something. 3 or 4 years later, we get royalties. Which is the bigger income stream? Royalties. Much, much bigger. These days, about twice as big as the licensing income. Our success is crucially dependent on the royalty income. So we have to ensure that our partners build successful products and sell them, because if they don't, we don't make any money. So we treat our customers as partners. Our success is truly predicated on theirs, and working together with our customers is absolutely everything. Timescales are very long. I've said quite a lot about that. That our typical product development to revenue cycles are numbered in anything up to 10 years for a product really to start generating revenue. People are the biggest asset we have. I did an exercise a while ago, just for my own benefit really, comparing the financial figures, the financial makeup of ARM in terms of our fixed asset register and the number of people we employ and what we're worth against another major semiconductor manufacturer. And other semiconductor manufacturers have fixed asset registers measured often in hundreds of billions of dollars because they have lots of foundries and they cost $5 billion apiece. So they have huge fixed asset registers. ARM's fixed asset register consists of about 30 offices and about 3,000 PCs. That's it. That's literally all we own. The rest of the value of the company is in the people we employ, not in the fixed assets that we have, because we don't have very many at all. The world is astonishingly diverse. So we have 50 nationalities spread across 30 countries. Our customers are even more diverse than that. And one thing we have learned is you don't do business with people unless you understand them, unless you take time to learn their language, to learn their culture, to learn how they do business, and to learn how they work, unless you take time to build relationships. The world is far more diverse than you could ever believe. Believe me, I've travelled around a large part of it, and I'm still coming across different cultures all the time. It does pay to be different. The easiest thing that ARM could have done right at the beginning, when it inherited a fully productized chip from Acorn, would have been to continue manufacturing that chip and selling it as a product on the open market. It realized, or Robin Saxby realized very early on, that that would involve a huge amount of financial risk. And it wasn't scalable. For a tiny 12-person company in Cambridge to start selling chips, forget it. They had to do something completely different. So they came up with this semiconductor IP licensing model. Nobody else was doing it at the time. Now everybody's doing it, even Intel. Listen to your customer and his customer. This is absolutely crucial. So we treat our customers as partners, and we listen to them all the time. We have to. We pay a lot of attention to our customers and what they're telling us. But we also listen to our customers' customers. If I take you right back to the most significant license that ARM has ever signed, it was a license we signed in 1993 with TI. I mentioned it on that history. TI, when they initially signed that license and went to Nokia with their design, failed to win the chip. Why? Because Nokia decided that code density was too poor. It's one problem with the 32-bit architecture. You have big instructions. So your code density is actually comparatively very bad. And the current memory cost ratio in the industry just could not sustain the code size that was needed for an ARM solution. So TI lost the design. Came back to ARM and said, no, sorry, not interested. ARM ARM came up with the solution to that, which is very innovative and very clever, and it's what we call the thumb instruction set now. It's to compress the instruction set into half the size. Very neat, very clever solution, implemented in about 12 months as a complete change to the architecture. We went back to TI and said, try this. They went to Nokia and won. Now that wouldn't have happened if we carried on talking to TI. It happened because we talked to Nokia as well. Nokia were not giving us money. TI were giving us money. And in the end, it was talking to our customer's customer that produced that. And we do that all the time. A lot of our marketing effort is not marketing to our customers. It's marketing to their customers to find out what their customers actually need. That's all I have to say. And I've talked for at least an hour. I'm more than happy to take any questions if anybody has any. I don't know how much more time we have, Stefan.
Yeah, we have time for questions and answers. If anybody's got a question. I certainly do have one I can kick off, which is...
Far away.
Can you remind me what code density is? Since I'm in the industry, I should know.
Code density. Code density is simply the memory size of the program related to its functionality. Okay. So in general, in crude terms, the bigger your instructions, potentially the worse your code density is. ARM has very big instructions, they're all 32 bits, they're all 4 bytes, and even to do a very, very simple operation like add 2 numbers together takes a 32-bit instruction, which is big. You could code that in something much smaller, and then you would get a much more compact program. That was the problem we had to solve.
Do you have any other questions?
I've been interested in communication channels. So you develop a product and you outsource the manufacturing part, because like that's internet manufacturing, because you want them to do a very good job at manufacturing the design. There might as well also be bugs in sort of like code design. What do you do with that? So how can you know about the manufacturing processes so that you actually can design them optimally for that?
Okay. We do have to know a lot about how our chips will be manufactured, yes. So we do have to know a lot about what goes on inside a chip foundry and the processes they use and the manufacturing technology they use. So we work very closely with what we call the EDA manufacturers, the people that design and sell the tools that people use to actually manufacture chips. So we do spend a lot of time working on that, we have to. And we work very closely with the major foundries in the world. There are several companies that have a lot of foundries. It's dominated by about 4 or 5 companies. But we work very closely with them, and we do actually license a lot of our technology directly to the foundries to ensure that they can do a good job of producing chips based on our customers' designs and based on ours. You know, we do have to spend a lot of time with that. You're right, yes. All the time. All the time, yes. Yes. I mean, the office I work in, so my main job is training, but the office I work in is our customer support office. We have 4 or 5 customer support organizations spread out, and they work supporting our customers and also supporting the foundries and various other people who are actually in the manufacturing process. Yeah, so the feedback comes back all the time. Yeah. Yeah.
You talk about licensing your technology. A couple of those in Beijing markets will then buy a Samsung S4 for 50 quid.
Yep.
So there's a kind of lack of respect for licensing. Is that an issue?
I'd be silly to say it wasn't. Our president, Judy Brown, who retired about 2 years ago, when we first started doing business in China, and we've been doing business in China for about 10 years now, he described China as ARM's greatest opportunity and its greatest risk at the same time. I think he summed it up absolutely right in that. The Chinese market has grown faster than anyone thought. The speed that they come up to grips with the whole chip design and manufacturing process has stunned everybody. But yes, you're right. They do have, sadly, a culture of lack of respect for design rights and patents and so on. But ARM has been extremely careful and cautious in the way we've gone into China. Yes, there have been attempts to either clone or steal our technology in China. So far, we have dealt with those, and we do not believe that anybody at the moment is misusing talk about software tools, that's a slightly different thing. Every time you produce a software tool, you get 10,000 copies of 10,000 web servers in China. But our IP is different. It's quite easy to find, and it's quite easy to prove if someone's missing it. And the Chinese industry, if you buy a phone these days,